Okay, so welcome to part 5, I think, or 6 of the scripting tutorial series. So today we're going to be going over built-in functions and events. So let's get started. So uh, built-in functions. So I'll give an example of a bunch of them and I'll show you how to see the rest of them. So the first built-in function we're going to be going. Okay, that was bad. The first built-in function that we are going to see is find first child. We already went over this, but I'll just show it again. So I'm gonna do workspace. Oops, that's the wrong one. Find first child, and I'll do part. So what find first child does is it returns. So it pretty much tries to find a part. So you give the name of the part or instance here. It tries to find it inside whatever parent you gave it. So it tries to find part inside of workspace, which will actually return nil because there's no part. So instead of doing workspace.part, which will give you an error, you can do workspace find for child part, which won't error, but it will give you a nil. So I'm gonna do local part equals, and I'm going to print part. So this will print nil instead of our. I mean, I'll show you quickly if you do workspace.part. You can see it will error. Part is not a valid member. So yeah, you will use find for child to see if an instance exists or a child exists. So if you do put a part in here, it will print out the part name part. So that's find first child. It's a very simple but a very common built-in function. So the next one actually will be wait for child. So wait for child. Let's do part. So what this will do is it will print child found. So what this will do is it will yield the script until it finds a child named part inside of workspace. So if I play this, it shouldn't print line 2 ever. Yep, as you can see, it never prints. And if we wait long enough, you'll get a warning called infinite yield possible in workspace wait for child part. So this pretty much means that it's possible for the script to stop forever because there's no part getting added. So yeah, that's wait for child. So let me do it again real quick, but let me add a child in here. So okay, let's add in a part, and as you can see, child found. So yeah, it will yield the script until it finds a part inside of workspace named part. So those are probably the most used built-in functions. The next built-in function is going to be get children. So pretty much get children is you specify what you want to get the children of, and then it pretty much loops through everything inside the instance that you gave it. So in my case, workspace. So it will loop through workspace and give you every single instance that's inside here, and it will return it in a table. So we have to loop through it. I'm gonna do that real quick. I just need parts, more logical. Here is parts 2. I'm just gonna print out v.name. So if I run this, it will print out everything inside the workspace. So that will be camera, baseplate, terrain, and spawn location. So yeah, that's another very useful function. There's pretty much a very similar one called get descendants. So before we took these 4, but get descendants also loops through each of the children to see if there's any more children, and it will also add them inside the table. So now if you run this, it will also print tcal and texture. So that's get descendants. Let me try something. Can I do game get descendants? I wonder. Oh, you can. This gives absolutely everything inside the game. Oh my god. That's kind of cool. I never done it. So those are the 3 most common built-in functions that people use. I mean, most of these are very self-explanatory. So yeah, you also use a colon to use built-in functions. That's pretty complicated to explain right now, so I'll not confuse you with that right now. I'll also show destroy real quick. So destroy is, I think, yeah, we already went over most of these, but I'll just explain them more in depth. So destroy pretty much, it doesn't return anything, I'm pretty sure. So if I go workspace.baseplate and I destroy it, it's very self-explanatory. It just deletes the item. It sets the parent to nil. And again, most of these are very self-explanatory. So let me just find something. So is a, so that checks if a part is like specific catalog. So let me do print workspace.baseplate is a, and I'll do if it's a player. So we're checking if baseplate is a player. Now what this checks, if it checks if the item or instance you give it is a certain class. So if you click on an object in the Explorer, and you go to the properties, this is the class right here. So camera class is camera, workspace class is workspace, texture, decal, and so on. So what this does is checks if a baseplate is a class of the player, which obviously is false. And we can also, so we can do part, it checks if it's a part, which is true. And you can also do base part. The difference between a part and a base part is that base part is like multiple parts. So it's like a part, mesh part, and unions as well, I think. So yeah, I'm not sure about unions, but I know that it's also a mesh part. So it checks if it's a base part, which is also true. It also checks spawn location as well, I think, because spawn location is a part of base part. So yeah, it does true. Okay, so that's is a. So yeah, you can just check them out, experiment with them. They all are very self-explanatory. So find for child, which is a, so it tries to find a child which is a specific class. Or this checks for a class, this checks for like base part or something. So yeah, so most of these are self-explanatory. Some of these others are more complicated, which I'm not going to go over. So yeah, those are built-in functions. If you want to see all of them, go to view and go to, I think it was object browser. Yeah. So here it gives every single class inside the game. So I'll go to part real quick, part, and here you can see all of the built-in functions. So built-in function icon has this, I think it's a bindable function icon. So yeah, built-in functions have this icon here. So, and these are properties, these blue boxes, and these are events, and these are, not sure what these are. Oh, they're also built-in functions. Actually, the next thing we're going to go over is events. So yeah, events. I'm going to explain them now. So events pretty much listen out for something to happen. So let's say you play a game and you click a button. Then event will listen out until someone clicks the button, and if it does, it will execute a line of code. So let's make a button. Okay, I'm just going to get a part here. It's going to be a pretty big button. Okay, don't have like a start. Let me do a start real quick. I'll just size it like 1, 1, 1. There we go. It is not going to line up, so that's going to be pretty annoying. Yeah, whatever, I'll just do it like this. Okay, it's a pretty big button. Make an actual button now here. Okay, I'm gonna model this button. I'm going to make this a neon red button like in every single game. and this is going to be the platform, and it's going to be like diamond plate. Oh, the purple looks nice. I like this. Okay, I'm going to name this button. So let's go over some events, and I'll also go over click detectors and proximity prompts. So I'm going to add a click detector. What a click detector does is it allows us to detect when a part is getting clicked on by a user. It has a couple of properties like max activation distance, self-explanatory, and yeah, that's pretty much the only property it has. Let's make a script inside here. We can also detect if the button is being clicked from this script, but it's just going to be shorter this way. So I'm going to make a variable for our click detector, because that's what's detecting the click. It's not the button, it's the click detector. So click detector equals script.parent. So what script means here is it's the actual instance. So if we say script, it's referring to this instance here. So we're doing script.parent. So script, the parent is button. So parent is going to be button. Then we do dot button, because then we can access the button. Dot click detector. So to detect an event, you use a period, not a colon like last time. So a period, and now the event name. In this case, we're going to use mouse click, so it detects whenever you click with a mouse. There's also, so there's mouse click. You can also detect if the mouse is hovering over the button or not, leaving the hovering mode, or if it gets like right clicked or something. I'm going to do mouse click, and now we need to connect to a function. So I'm going to make a function real quick. Local function clicked. Now, to connect to a function, you do colon, connect, and the name of your function. And if you read up here, we can see that you can actually get the player who clicked it, so we can add player parameter here. We don't call the function, it connects to the function, so it's different from calling. And this, you can pretty much imagine, so whenever pretty much we connect to a function, so when we connect to this clicked function, you can kind of imagine it doing this. So we're pretty much sending over the player who clicked it. So if we print player.name clicked the button to play. So if we click it, it prints out that we press the button. So yeah, it's an automatic argument. It sends over the player who clicked it. So we can actually just not like make a function for this. We can actually connect to a function that we make. So yeah, we're pretty much connecting a function that we just made. You can't like call this anyway. There's no way to call it. It only can be called whenever the mouse click gets activated. So this might be pretty confusing. I don't have a good way to explain it. You just kind of get used to it. And to get the player argument, you put it inside these parentheses here. So player. And we can just print, I'll do player.name. And it will work the exact same, but it's just, I don't think, no, it's shorter definitely. So yeah, it works the same. So we're just connecting to a function that we just made. So that's mouse click. I'll quickly delete this and I'll show you some other cool events. So one of the events can be accessed by the player service. So game.players, and now we want to access an event. So game, and I'm going to player added, so we can read about this as well. Fires when a player enters the game. So yeah, by fires it means like when a player joined the game. Oops, I gotta connect function. Boom. So whenever a player gets added, and we can only detect if a player gets added through the player service. So whenever a player gets added, we can connect to a function, and this also has an argument or a parameter which gives the player who joined. So we can print player dot name joined the game. So if we go in now, it detects that we joined the game. I forgot to put a space in between. So yeah, there's also a very similar one called game.players.player_removing connect function player. So this will print whenever a player leaves the game. Okay, if you leave the game. Yep. So again, most of these are very self-explanatory. I'm not sure if there even is any more events beside those. Obviously we have child added, so this fires whenever a child gets added, and it gives you the child that gets added. There's destroying, so whenever you destroy an instance, and so yeah, so you can detect when a part is getting destroyed and quickly run some script before that. Child removed, so whenever a child gets removed, ancestry change, so whenever something inside the ancestry changed. So yeah, as you can see, most of these are very self-explanatory. There's nothing to really explain about them. I'll also show you proximity prompts real quick and touched. So to show you how touched works, I'll just quickly make a banana script. So whenever you step on a banana, it makes you sit down or slip. Okay, got a model real quick. It's a mesh part. I'll name it banana. Okay, let's see. I'm going to make it can collide on anchored off. Okay, good. So to detect when a part gets touched by something, we're going to have to use script.parent. So this will be the banana. And to detect when it gets touched, it's very simple. It's just touched. Connect function, and this is the hit. So whatever hit the banana. So let's print out hit.name. If you click play, as you can see, it touched the base plate, so it prints out base plate. And if we touch it, as you can see, it prints out all of these, and it just got flung, so it touched the plate a bunch more times. So let's make the script actually like make us fall lower. So first off, we have to get the character. So local char, short for character, equals hit.parent.parent. So the reason why I'm doing hit.parent.parent and not .parent is because R15, so when you have the like non-blocky character, you need to do .parent.parent twice for hit. For R6, it's just hit.parent. So this will be the character print hit. And obviously it's going to touch the base plate. It's either going to error or something. Never mind, it's base plate. So if we now touch this, I think I just print hit. I gotta print char. So it prints out game because it goes banana.parent.parent, which is game. So if I touch this, it's workspace. Okay, no, was it script.parent and hit.parent? That's weird, I don't know. It's workspace, and if I touch it, I swear to god it was hit.parent.parent, but whatever. So we have, I'm going to actually change the game to R6 real quick. I'm going to see if there's a difference. Either they like changed it or something. Yeah, you used to have to do hit.parent.parent for R15, but I don't know. I guess they changed it. So now we have our quote-unquote character, because anything can touch it and it'll get the parent of that. So how to make sure that it's a character? Well, we're going to use a built-in function called getPlayerFromCharacter, which is self-explanatory. So to detect if it's a player, let's do if statement and detect if game.players get player from character. This takes in a model and it will check if it is a player. So I'm going to char, then do this. So it goes to the player service. It tries to get a player from a model, so hit.parent, and if it can't get a player from the model, then it returns nil. And if it's nil, the if statement won't run. So in here, we already know that it's a player. So we need to do char.humanoid.sit equals true. So we're accessing the humanoid. The humanoid has a bunch of properties, and in this case, we're accessing the sit property, which is a boolean, and we're setting it to true. So now, if you touch the banana peel, we will sit. So that's how we can make a simple banana peel script. If you were to remove the if statement, it will just error because we don't know if it's a player. So as you can see, humanoid is not a valid member of workspace. It will still work, but errors are never nice. So that's touched. And you can easily make it a kill brick as well. So if I take this back, I can just do humanoid dot health equals 0. So now it's pretty much a kill brick or a kill banana peel. So yeah, humanoid has a bunch of properties that you can mess around with. And the last event that I'll show you is a proximity prompt event. I'm going to make a part here, add in a proximity prompt. This is a bunch more properties. Hold duration, I'll do 1. Keyboard code, I'll do it E. 10 distance, requires line of sight, so you have to like have a you need to see it with your head, or it's the easy way to explain it, I guess. Add in a script. Actually, I'll add it inside proximity prompt, so I can do script.parent. And proximity prompt to detect when a proximity prompt is complete, you use triggered connect function, and this is the player who triggered it. So player, and we can print player.name. I'll use activated, makes more sense to me. Activated box. If you click play, we can go up to the proximity prompt and activate it. And as you can see, Kekikoa activated the proximity prompt. So yeah, those are the like more important built-in functions events. Obviously, like I told you before, you can go to the object browser and find your class. So I can go like, where's player? Players. Is there no player? What the hell? Okay, I guess player is not like a thing. So yeah, as you can see, part, it has touched ended. Whenever you stop touching a part, the send and removing. So yeah, you can see a lot of useful stuff here. So yeah, that's the end of this tutorial. Next video is about instancing and cloning. So yeah, for the daily challenge, I'll just like, so for the daily challenge, just make a like pretty much a border, and when a player touches it, just kick them out of the game. It's like a anti-cheat border, I guess. So yeah, pause the video, try to make it. It should be like 3 lines. So it's a pretty short challenge, but it should give you an example of how to use object browser. So I'm going to make it right now. So if you haven't made it yet, go and try it out. But I'll make it real quick and show you how to do it. Let's make a part here. And to make sure that the player can get inside of there, I'm going to do can collide off, put can touch on, because dot touched can be used as long as can touched is enabled. Can collide can be off, it doesn't matter, it doesn't change the event. Going to do anchored on so it doesn't follow through the map, and I'm going to set it to 0.5 and I'll make it red. Adding a script here, so script.parent.touched. I want to connect to a function with the hit, and I'm going to make local char equals hit dot parent local player equals player, actually equals game.players get player from character char. Now I want to check if there's player. So if player, then I want to do player pick. So yeah, and this is a built-in function. So it pretty much, I hope you found it. If you did try to do the challenge, pick, you touch some brick. I had caps lock on. So if you click play, the kick takes in an argument or a optional argument, which is a string, which is the kick reason. So if you go in here, you touch it, you touch some brick, and you get kicked 7 times. Oh, it actually gives an error message. That's cool. So yeah, that's everything for this tutorial. I hope you completed the challenge. I'll see you in the next video. Goodbye.